Are we good to go? Good. All right, so this is thorium. This little ball of thorium, when used in a liquid fluoride thorium nuclear reactor, this tiny little ball can produce enough energy to last you a lifetime, or you a lifetime. It lasts the average American citizen a lifetime. Just that little tiny little golf ball sized nugget. Because thorium nuclear power is so efficient and so effective. Now, I went over in my last speech how our energy system is just not, it's not up to par. We're polluting our planet, we're spending lots of money we don't have, and we're really doing terrible things for our resources. Now, according to the EIA, last year alone, we used, I'm sorry, this was in 2007, we used 5 billion tons of coal, 31 billion barrels of oil, and 5 trillion cubic meters of natural gas. And this is all together to produce electricity for, this is the world in general. But I'm here to tell you that with thorium nuclear power, we can produce this amount of energy with just 5,000 tons of thorium. Now, a big question that would come up is, why would we use nuclear power over, say, solar or wind? Now, in this study from Jason Morgan of Nuclear Fissionary, which was published on April 2nd, 2012, we found that nuclear power will cost less than half a comparable solar power system. And this is even factoring in fuel, security, and maintenance. Nuclear power costs will be about 4 cents per megawatt hour, whereas solar power would be like 22 cents. Natural gas, you can see, is around 11, wind up at 8. Coal is around 5, hydroelectric is at 3%, 3 cents. So as you can see, nuclear power is definitely among one of the cheapest ways to generate power in the United States, but some of these other ones that are also cheap have very drastic side effects from using them. Coal, natural gas, very dirty. Hydroelectric power, ruin ecosystems because you're separating 2 different bodies of water. Now, on May 4th, 2012, this guy named Kirk Sorensen gave a lecture on liquid fluoride thorium nuclear power. Now, he worked at NASA as an engineer for over 10 years. He was also a chief nuclear technician for Tetteline Brown Engineering. And he was talking about the way that our nuclear power system works right now. We use uranium in our cores right now. And when we use uranium to produce nuclear power, we use about 0.7% of that uranium. Whereas when we're using thorium power, we're able to use over 90% of it. There's also dangers that come with using this. We use a water reactor. We pressurize things and use it to the reactor, but since we have to keep the uranium at such a certain temperature, we need water, and that water needs to be pressurized, and when that water is pressurized, it turns into steam, and the steam actually expands by a factor of 1,000 during this process, which becomes very dangerous if any slight calculation is wrong. It can cause explosions. It's very dangerous. So according to this guy Sorensen, he said the reactors we have today use uranium oxide as fuel. It's a ceramic material that's chemically stable but not very good at transferring heat. If you lose pressure, you lose your water, and soon your fuel will melt down and release radioactive fission water with it. So not only are we at risk for explosions with this type of nuclear power, but you're at risk for releasing radioactive material and contaminating a site. Now, we saw something like this happen at the Fukushima Daiichi plant in Japan in the last tsunami. Now, although they did have diesel reactors that were set up that had a very high probability of going on, when they were hit by the tsunami, the electricity in the system stopped working. And that's where the big scare came from, that we were like, what is going to happen? Is there going to be radioactive materials going all over the place? Is it going to explode? We didn't really know. But there are reasons why thorium is much better than using these water-powered uranium reactors. First of all, it's more efficient. According to Wickler's The Chemistry of Actinide and Transactinide Elements, thorium is in fact several hundred times more common than uranium-235, which is what we use in our reactors. Also, as I showed in the first example, you can fit a lifetime of energy in the palm of your hand. It's also 200 times more effective than using uranium. And because of this, it becomes cleaner because we're using almost all of the thorium compared to just a fraction of a percentage of the uranium. So we'd actually reduce the waste of using these uranium reactors by a factor of hundreds. And compared to fossil fuels, a factor of millions. Millions. Now, because we don't use solid metals in this process, we use thorium, it's in its liquid form. So we don't need to use water to keep it stabilized. That means we don't have to use high pressure. So the risk of explosions is also just not there. Now, this is a slide of a thorium reactor and how it works with the safety process, because we're scared of what's going to happen if the electricity goes out. Well, what we have here, there's a salt plug right in here. And that salt plug is frozen, and it keeps all the liquid in the reactors spinning around there. But if it were to lose power to the reactor, if like there was no electricity, then the little gas blowers that actually keep the pipe itself cool would stop functioning, making the salt melt. And then the liquid fluoride actually runs down into this drain tank here that contains all the radioactive material. So it's very safe. We have a fail-safe with this that we don't see when we're using these uranium reactors. According to Sorensen, in water-cooled reactors, usually you have to provide power to keep water circulating and prevent it from meltdown. But if you lose power in this system, the lifter actually shuts down itself without any human interaction. So basically, thorium is just a much better option than anything else that we've seen out there. Oil and coal, we've been over this, they're dirty. They're cheap, but it damages our environment. Wind and solar are impractical, they just cost too much. And hydroelectric, although it's cheap, it really damages our ecosystems. Now, nuclear is still the cheapest with just the water, one of the cheapest options we have with just the water reactors that we're using now. But if we were to convert to thorium, it'd be exponentially cheaper. We'd see prices at about 1/50th of a penny per kilowatt hour compared to the 4 that we were seeing with just the water reactors. In closing, the liquid fluoride thorium reactors are cheaper, safer, cleaner, and more efficient than any other energy source we have. I believe that if we implement them in our energy system, we will have no energy crisis on our hands and be seeing nearly limitless renewable energy. Thank you.